is I want us to just recap what is happening in a square root. So this part right here, that is the part that tells us what root we're taking. It can be a square root, cube root, fourth root, fifth root. That is telling us the root we're taking. And that is called the index. Okay. I often refer to it just as the root. I don't hardly ever say index, but it tells us what root we're taking. And then the actual symbol itself is the radical. And then whatever is underneath the radical is called the radicand. All right. Now, if we have a radical that does not have a root on it, what is the assumed root that it is? It is an assumed square root, okay? So over here it said if there is no index, it is assumed that n equals 2. Now, one of the most important things for us to remember this unit is our perfect squares. So let's write out, we're actually going to list out not just 1 through 12, but we're going to list out 1 through 15. So what is 1 squared? 2 squared? 3? 4? 5? 6? 7? 8? 9? 10? 11? 121? 12? 13? 169? 14 is 196. Those two just flip-flop, which is how I remember them. And then 15 is going to be 225. So if you know your perfect squares, it will make simplifying radicals and evaluating them a lot easier. Okay? It'll also make solving equations with square roots so much easier. So number 1, what is the square root of 16?
2. Oh.
It is 4.
I thought it was like what?
No, we are just dealing with square roots because we are just dealing with quadratics. Quadratics have an exponent of 2, so we're only going to be using square roots, which is why we are quickly recapping just our square root rules. So for number 2, it says 2 times the square root of 121. So to do this, we're going to do 2 times, what is the square root of 121? So what is 2 times 11? All right. Number 3, we have 6 times the square root of 289. So 6 times, what is the square root of 289? 17. Okay, so what is 6 times 6 times 17? 102. Then number 4, we have 3 times the square root of 400. So we get 3 times, which is going to give us, perfect. So obviously when they're perfect squares, it makes it easy, right? But what we have to do is we have to look whenever we don't have perfect squares. We're going to look at how to simplify those, okay? Because what happens when we don't have perfect squares is if you plug them into the calculator, you're going to get some big long decimal. Okay, that decimal makes it an irrational number. It goes on forever and it does not stop. Even your calculator is having to round it as it goes. Okay, so most of the time, like let me see this. So if I plug in the square root of 3 into this calculator, I get 1.732050808. And even if I take that same number and square it, a lot of times you'll still get like a 0.000000001 because it's rounding somewhere, okay? Now, not all calculators will do that. Like this one will automatically tell you it's 3. But if you use a slightly less smart calculator and you tried that, it'll tell you 3.00001. So to avoid all of those rounding errors, we are going to leave them as radicals. But before we do that, we have to simplify them. So what we have to do is we have to figure out what of the perfect squares the radicand is divisible by. So we have to figure out whatever the biggest perfect square the number underneath our radical is divisible by. So for number 5, what is the biggest perfect square that 32 is divisible by? 32 is not divisible by 5.
25.
It's not divisible by 25. 16. Because 32 divided by 16 is 2. So what we're going to do is we're going to rewrite this as square root of 16 times the square root of 2. We just take it and split it into a perfect square and a non-perfect square. Then we evaluate the perfect square. What is the square root of 16? So our answer would be 4 root 2. And that is how we leave it. Okay? And that lets our answer, even though it's irrational, still be in an exact form with no rounding. Okay? So for number 6, what is the biggest perfect square that 180 is divisible by? 13 is not a perfect square.
Wait, I'm confused. So it's not like you don't use these?
You do. The biggest perfect, like you have to use the list of perfect squares. Like 180 is not divisible by 169. Okay? You have to find 36. Okay? So we can break that up and say 36 times 5. Because 36 is the biggest perfect square that 180 can be divided by. Okay? You can think of it as 36 is the biggest perfect square that can go into 180. I'm not talking addition. I'm not talking subtraction. I am talking division. Okay? So what is the square root of 36? So our answer for this will just be 6 root 5. I've got to bring WD-40 for this chair. I'm so sorry. All right, number 7. 147. What is the biggest perfect square that can go into that? 49. So we can break that into the square root of 49 times the square root of, it's 49 times what? So what will my answer be? 7 times the square root of 3.
Wait, where did you get 3 from?
49 times 3 is 147. All right, number 8. What is the biggest perfect square that can go into 175? 25. How many times can 25 go into it? And then what will my answer be? 5 root 7. I want y'all to do number 9 for me. Figure out the 2 numbers that we can break 48 into. The biggest perfect square that 48 can be divided by.
Wait, how do you figure out what the outside is again? Like for the semicolon?
For like the solution, you evaluate the perfect square that you find. What's the biggest perfect square that can go into 48? How many times can 16 go in?
3.
So what's the square root of 16? So we get 4 root 3. Because we can take this square root, but we can't take this one. Number 10. So number 10 is the same thing, except it's saying 2 times the square root of 54. So we're going to have to say 2 times the square root of the perfect square and the other number. What is the biggest perfect square that can go into 54? 9. How many times can 9 go in?
6.
So we get 2 times, what is the square root of 9?
3.
And then we have times the square root of 6. So what should my answer be? 6 root 6.
Wait. Oh, so we just if we have a number in front of it, we
It just gets
multiply.
multiplied. Yep. All right. So all of these are us just dealing with the radical. So on the next page, we're actually going to put them into the equations. So we can only solve some quadratic equations by square roots, okay? So they have to be in the form of ax squared plus c equals 0. They can have no bx term, okay? They should have no term with just a plain old x in it. It'll have an x squared and a constant. And then we're going to actually look at an example of how to do this. So we solve this just like a normal equation. We have to isolate the x squared. We have to get the x on a side by itself. So how do I do that here? Plus 49 on both sides. So we get x squared equals 49. Now what? How do I undo a square? Square root. So we get x is equal to 7. Now, there is a catch when we plug it into an equation. So, whenever I just ask you, hey, what's the square root of 49? And you say 7, that is fine. But when we put it in an equation, we have to think about all of our scenarios. There is another number we can square and get 49. What is it? Negative 7. So our answer for this should be positive and negative 7. And so that means when we put it as a solution set, when we do x equals our squiggly bracket, it'll be negative 7, comma 7.
But wouldn't that be negative 49?
Negative 7 times negative 7 is positive 49. Because when you multiply a negative and a negative, you get a positive. So that is why we have to do both of those cases. Okay, so I want us to look at, we're going to go through all of the odd problems plus number 8. Okay, so for number 1, what do? Add 16. So we're going to get x squared is equal to 16. Then what? And so x is going to equal positive and negative 4. So our solution set would be negative 4. And this, you end up with both solutions for the same reason you end up with the difference. You know how we factor difference of squares? That's the same thing we're doing here because that is a difference of squares problem. That's x minus 4 and x plus 4. That's the same thing that's happening to get those solutions, okay? It's just, it's happening, and we're doing it a different way. We're not having to factor that, okay? We can just solve it straight through. We're going to talk about it. So for number 3, what do we do? Subtract 25. So we get x squared equals negative 25. We take our square roots. Can we take the square root of a negative? So what did you say it was, Gabby? No real answer. The specific part of that is the real part, okay? No real solution. And that's just because we do not currently have the tools in our toolbox to evaluate that. We will get them. We're actually going to get them when we come back from spring break. That will be the first thing we talk about, okay? But for right now, we can leave it as no real solution. Okay, because we don't currently have the skill to do that yet. So now for number 5, what do I do for number 5? Add 5. So we get x squared equals 1. How do I solve from here? So I get x is equal to positive negative 1. So our solution set would be negative 1, 1. Now we're going to do number 7. Okay, for number 7, what do? So what is negative 98 divided by negative 2? 49. And so now we just have the same problem we started with. So what is my answer going to be? positive and negative 7. Okay, because when we take the square root, we get x is equal to negative 7 and positive 7. Kinetics. All right, now we are going to look at number 8. Does anyone remember how to get rid of multiplying by a fraction? Yes, and what would the reciprocal be here?
4 over 3.
So we multiply both sides by the reciprocal. When we do that, this part will completely cancel out, and we just get left with x squared. Now on this side, that is technically over 1. If you type it in your calculator using fractions, it'll spit out the exact answer. You can also just say 48 times 4 is, divide that by 3.
64.
Is what?
64.
Perfect. Okay, so that is what that is equal to. So now what do? Take the square root. So I get x is equal to positive negative 8. So we would write our solution set as negative 8, 8. And yes, we are going to keep writing our answers like that. Okay, on this test, every single answer should be written in that form. Okay, because we're solving quadratic equations with different methods, right? Every single one of them, we're going to write our final answer the same way. That'll make it super, super easy for me to go through and go, whoop, squiggly bracket, and grade them. Okay? Now, that being said, if you forget squiggly brackets, I'm not evil, I will give you partial credit, but I want those squiggly brackets. So let's work on them. Because some of y'all squiggly brackets, I was looking around the other day. Woo! I should have yelled at y'all about the squiggly brackets yesterday, too. Yes, I'm making a joke about it. I am sorry for getting frustrated at y'all, yes.
As long as you can tell it's a squiggly bracket.
It'll be okay. But please do try to refrain from writing 3s. Okay?
No real solution.
For number 9?
0 divided by 3, you can do that.
Yeah, you can. But that's not what we're doing. So I have to add 108 first. Okay? So we get 3x squared equals 108. Okay, now what? Divide by 3. So when we do that, we get x squared equals 36. Now what do?
Divide by
So we get x is equal to positive negative 6.
2018-63, Tony Ward, booking on Henry Smiley's bus 2023-96. We hope you had a terrific Thursday here with us. We'll see you back for a fantastic Friday.
That was short announcement
Have a
stuff.
great day, good morning. Enjoy this beautiful weather. Bye.
All right, let's get to the back. All right, so I want us to look specifically at questions 13 and 15. So for question 13, okay, what do we do? Add 16. Okay, so we get 9x squared is equal to 16. Now what? So y'all get x squared equals 16 over 9. Now what? I still have to. Okay? No. So the cool thing about square roots is if I take the square root of a fraction like that, that is the same exact thing as if I was to say the square root of 16 divided by the square root of 9. So it's actually going to be positive negative. What's the square root of 16? What's the square root of 9? So we get x equals negative 4/3 and positive 4/3. I have years of practice. I had the realization earlier today, I made the joke. I was like, I've been doing it. Somebody said, why do you write math so fast? And I was like, I've been doing it longer than you've been alive. And I went, that's actually true. That's crazy. It made me feel real old. Like, I've been doing algebra longer than y'all have been alive.
No.
Like, basic equations, yes.
You would have been like for over
16 years.
I would have been 11, actually. But no, yeah. You do, like, equations, and I skipped a grade, so I went into kindergarten.
What grade did you
Well,
skip?
I didn't really skip a grade. They let me start kindergarten a year early because I could read.
Oh, I love that for you.
Fair enough. So, but Yeah. I've been doing math for a long time.
I'm sure.
You do like X, like you do equations, like,
Yeah, we started on.
yeah.
Wait, 6x.
You do simple equations when you're that age. I think you started in 5th grade. You throw in.
Fifth grade was good.
Oh.
Yeah, but 5th grade was our coding.
That explains so much.
That's why we're so bad at fractions. That's why I'm so bad at fractions.
Our 5th and 6th grade, we didn't go back to actual school till the middle of our 6th grade year. And was
That
only
explains a
18
lot.
minutes.
That explains a
And
lot.
when we started fractions was the end of 5th grade year, and that's when we got out.
That explains a lot.
Ms. Dawson, did you graduate college early? Did you start?
I mean, I graduated the year, like 4 years after I graduated. When I graduated college, I was still 22.
Oh,
Fair enough.
so you were always the youngest in your grade?
Like when I started college, I was 17.
That's good. Did you go right after you were
Depends where your birthday falls.
I'll be 18 September year of senior year. No, she turned 18 right after she graduated. She turned,
Yeah.
graduated in May, and then turned 18.
All right, now. I dropped my pen. For this one, okay, what do I need to do? I can add 1 on both sides. Okay, that's an easy thing to do.
Oh wait, can you subtract to it?
Ooh, we can. So we got 5x squared equals x squared plus 1. We can subtract x squared on both sides. What is 5x squared minus 1x squared?
4x squared.
Equals 1. And then we divide by 4. And it's one of those little pesky fractions yet again. So we get x squared equals 1 over 4. What do I do? So that means my answer is what? All right. Now, we're going to spend the last couple minutes looking at ones that are going to have those irrational numbers where we have to simplify the radical. Okay, same thing, it's just we're going to have to simplify radicals. So, let's look at number 17. So, 17. What do I do? So, we get x squared is equal to square root both sides. Can I take the square root of 3? No. No perfect squares can go into 3. So what we're going to do is we're just going to leave it as positive negative root 3. And so we would write our solution set. That's a very bad squiggly bracket. Negative root 3, comma, positive root 3. All right. Number 19. Y'all ready? What do we do? So we get x squared. Y'all, we're not done yet. I'm going to let you have time to pack up. We're just going to do at least one more problem. What do I do from here? Yep. How do I undo the x squared? And so we have to break that 48 apart. What's the biggest perfect square that can go into it? And it goes into it how many times?
Wait, then why didn't we break apart 3?
Because 3 can't be broken apart. So it's just a square root of 3. Okay, so this one we can break it apart because the perfect square of 16 can go into it. So that means that x is going to equal positive negative 4 root 3. Because again, we can't do anything with the root 3. So we just kind of leave it there. Yes?
So we put all that inside squiggly bracket.
Yes. So your squiggly bracket would say negative 4 root 3. I keep forgetting things. Positive 4 root 3. Okay, and we are going to wrap up, do a couple more of those today or tomorrow, and then we're going to start completing the square.